Today we're going to be talking about a problem that involves acceleration. As a car comes to a sudden stop to avoid hitting a dog, so think about that, as a car comes to a sudden stop. So that means the final velocity is going to be 0. Let's take it a little further. As the car comes to a sudden stop to avoid hitting a dog, it accelerates uniformly at negative 3.6 meters per second squared. So we'll talk about that in just a minute. And it does this from 8.65 meters per second to 0. Find the time interval of acceleration for the car. All right, so let's go ahead. The first thing we want to do is kind of visualize what's going on. So you got a car going along at 8.65 meters per second. Driver sees a dog, hits the brakes. Car begins to slow down, slow down, slow down, slow down, and comes to a stop. The rate at which it actually accelerates or slows down is negative 3.6 meters per second squared. And we want to find how long does that take? What's the time that that takes? All right, so once you've got this in your head, once you can visualize this, now we got to create a simple physics diagram to kind of graphically illustrate this. All right, so this is what it's going to look like. Here's the car. So I'm going to draw the car as a dot. Car is a point mass. And let's say the car is going in this direction. And I'll make that my positive direction. So there's the car. It's got an initial velocity of 8.65 meters per second. So when the problem starts, that's how fast the car is going. And then it slows down, slows down, slows down, and stops. Make sure you label your diagram kind of like this, right? There's the initial velocity. I like to put that at the beginning of my diagram. Here's the final velocity. You know, it makes sense to put that at the end of the diagram. And then we've got an acceleration throughout that entire length. So the acceleration is negative 3.6 meters per second squared. And we want to know how long does it take for this to happen. So I'm going to put a time there. That is my unknown. So now I've got a simple physics diagram, and I've got my known and unknown information. So let's just talk about what this actually means. So again, the car is moving along at 8.65 meters per second, and then it begins to accelerate. In this case, it begins to slow down. All right? So you notice the negative 3.6 meters per second squared. So what's that? That's telling us that every second this car is losing 3.6 meters per second of velocity. Now most of the time, a negative acceleration is going to mean slowing down, but not always. So the rule goes like this. How do you know whether it's speeding up or how do you know whether it's slowing down? Well, the way you know this for sure is this. You take a look at the acceleration and you take a look at the velocity. And what we really care about is the signs. So here I've got a positive velocity. My velocity is in this direction. It's in the positive direction, in this case to the right. And my acceleration is in the negative direction, to the left. So think about that. If a car's got positive velocity and a negative acceleration, those things are opposite each other. That's going to cause the object to slow down. Let's just assume that this was positive and this was positive. If both are positive, if I've got an object going in a positive direction and it's got a positive acceleration, it's actually going to speed up. Or take the opposite. If I've got an object going in the negative direction and the acceleration is also negative, it's going to speed up in that direction. So the general rule is this. If the acceleration and velocity, if the signs are both positive or both negative, right, meaning they're both the same, then the object's speeding up. If those two signs are negative, and it doesn't matter which one's positive and which one's negative, as long as they're opposites, the object is slowing down. And that's what's going on here. I got a positive velocity and I got a negative acceleration. So the car is slowing down. In this case, it's losing 3.6 meters of velocity each and every second. All right, Now that we've got that, the next part is to come up with an equation. And we've got several equations to choose from, but how do you know which equation should I choose? That's always a difficult part right there of problem solving. Well, first of all, you want to choose an equation that's got time in it, because that's what we're looking for. So that's a must. Your equation has to have time in it. So put a little check next to the equations that have time in them. You can kind of narrow the number of equations down. And then secondly, take a look at those equations that have time, and which of those equations contains the other information that you have available. And that's the equation you want to choose. Now, sometimes more than one equation will actually do the trick. In that case, how do you know which one to use? Well, whatever one pops into your head first. That's the one I use. All right, so it kind of works like that. In this case, I'm going to use this equation. I'm going to use acceleration, average acceleration equals the change in velocity over time. Now, whenever I see change, that's what this little triangle means, I want to expand that. And I like to do it on paper, not in my head. I find if I do it in my head, sometimes I mess up a calculation. So I like to write it down. If I can write it down, there's less of a chance that I make a mistake. If I can see it, I'm better. All right, so there we go. Change always means final minus initial. Now, once I got my equation all set, I want to go ahead and I want to substitute in. Let's just make sure that this is the right equation. I'm looking for time, right? Yep. Do I have the other information available? Yes, I have the acceleration. Yes, I have the final velocity. And yes, I have the initial velocity. And we're looking for the time. Understand that time needs to come out positive. Time should always be positive. And if it's not, go back and look at your equation. Something's wrong somewhere, right? So time should always come out to be positive. So let's make sure it does here also. So I'm going to go ahead and I'm going to put in a negative 3.6 meters per second squared for my acceleration. Don't forget the negative. Velocity final is 0. Velocity initial is 8.65 meters per second. And then there's my time. I'm looking for that. Now, take a look at this. I want to get t all by itself. So in this case, I got to multiply both sides by t, because I want t in the numerator. So if I multiply this side by t, I get that. If I multiply this side by t, my t's actually cancel out. And now I got t times this equals negative 8.65. I got a negative and a negative. Two negatives are going to make a positive. So I'm going to get a positive time here. So the last little bit here, right, I want to get time all by itself. So I'm going to divide both sides by 3.6 divided by negative 3.6. This cancels out. Time equals negative 8.65 divided by negative 3.6. So what that works out to be is 2.4. So time is going to come out to be 2.4 seconds. And I'm going to go ahead and put a box around it, and we are finished. So it takes 2.4 seconds from the time this person begins to slow down until they come to a complete stop. And that's it for this problem.